Okay, today we're going to find the zeros of a polynomial function and factors for the polynomial function. And this is the second part of the last video that I taped. First of all, when you're finding the zeros, you can start by graphing the function. When you graph the function, you can see that it touches the x-axis at positive 3, and wherever it touches the x-axis is the real zero for the function. And this one touches the x-axis at positive 3, so that's a real zero, and that means that either we're going to have some multiplicities, or we're going to have other zeros that are imaginary. Okay. Now, since it doesn't cross the x-axis at positive 3, it just kind of hits the x-axis and bounces off, that means that there is an even multiplicity, which means that answer, positive 3, it has a multiplicity of 2, or possibly a multiplicity of 4. Since it's a fourth degree function, it has 4 zeros. But it has to have at least a multiplicity of 2 because it doesn't cross the x-axis. If it crosses the x-axis, it can have an odd multiplicity, but if it does not cross, it has an even multiplicity. So we know there are 4 zeros, and we know that x equals 3 is one of those zeros, and it has some kind of multiplicity, either a multiplicity of 2 or 4. We've got to do some work to figure that out. So we're going to use 3 in synthetic division. Remember, in synthetic division, you look for the correct order of the terms and missing terms. This one doesn't have any missing terms. This is x to the 4th minus 6x cubed plus 10x squared minus 6x plus 9. Your coefficients for synthetic division are 1, negative 6, 10, negative 6, and 9. Remember, we begin by bringing down the 1, and after that we repeat our process, multiply and add. We take 3 times everything below here, so 3 times 1 is 3, add negative 3. 3 times negative 3, negative 9, add 1. 3 times 1 is 3, add negative 3. 3 times negative 3 is negative 9, remainder 0. Remember, you're finding zeros for the function, so you should always get a remainder of 0. This lowers it to a third degree. So now we're going to use our new coefficients in our next synthetic division step. So we're going to use these coefficients. We're going to use 3 again, only because we know it's got a multiplicity. It has to have at least a multiplicity of 2, which means we can use it 2 times in synthetic division. We're going to bring down the 1, multiply and add, multiply, add, multiply, add. 0 again. Lowers it to a second degree. Every synthetic division step, since you're dividing out 1 degree of your variable, it lowers it 1 degree. It's important that you keep up with your degree so that when you get to this point, you know that this is your coefficient for your x squared term, your x term, your constant. Now you have an equation, x squared plus 1, and you want to always get down to a second degree because that gives you a quadratic equation that we can solve by factoring the square root method quadratic formula. When you set that equal to 0, remember this 2 indicates that you're going to get 2 answers out of this. Since you've got a square and a constant, I would use the square root method. Move the negative 1, or move the 1 over and it becomes negative 1, so x squared equals a negative 1. When you take the square root, remember that a plus or minus always goes in with a square root when it wasn't in the original problem. And the square root of negative 1 is 1i, or just I. So your last 2 zeros are positive and negative I. So whenever you look at these in conjunction with the zeros you used up here in your synthetic division, you've got 3 2 times, which means it has a multiplicity of 2, and then you have x is positive I and x is negative I. So those total your 4 zeros that you need for the function. And remember that when you have imaginary zeros, they have to be in pairs, and they're always conjugates of each other. Now, as far as the factors for this, when you're factoring a function, your factors are directly from the zeros. X equals 3 comes from a factor of x minus 3. Set this equal to 0, you get x equals 3. The multiplicity of 2 means that I square that. It means that I actually have 2 of those factors, both equaling 0. X equals I comes from a factor of x minus I. Set it equal to 0, x equals I. X equals negative I comes from a factor of x plus I. So those are your factors, linear factors. They're all first-degree factors, linear factors, and your zeros. 4 zeros, multiplicity of 2 here on 3 gives you 2 zeros out of this one with multiplicity of 2, and then here's your third and fourth zero. So those are the zeros for the function.